Let's look at some application problems involving definite integrals. The first one here, Sweet Peas Ice Cream finds that the marginal revenue in dollars from the sale of X pints of butter pecan ice cream is given by R prime of X equal to 2 times X to the 1/6. Find the revenue when 300 pints of butter pecan ice cream is produced. In order to find the total revenue when 300 pints of butter pecan ice cream is produced, we need to integrate to find R of 300. So here we need to integrate over the interval 0 to 300, where our function is the marginal revenue function with respect to x. So here that's going to look like the integral from 0 to 300 of 2x to the 1/6 dx. So we need to find the antiderivative of 2x to the 1/6. So that's going to look like 2, and then we need to add 1 to the exponent. 1/6 plus 1 is going to be 7 over 6. And then we need to divide by 7 over 6, which is equivalent to multiplying by 6 over 7. And then we're going to evaluate this integral from 0 to 300. So that's going to look like 12 over 7x to the 7 over 6, evaluated at 300 minus what we get when we evaluate at 0. So plugging 300 in, we have 12 over 7 times 300 to the 7/6 minus what we get when we plug 0 in. So 12 over 7 times 0 to the 7 over 6. Well, that term's going to go away because that's 0. Plugging this into our calculator, we get an answer of $1,330.63 when we round to the nearest cent. So this gives us the total revenue when 300 pints of butter pecan ice cream is produced. In the next problem, a particle is released during an experiment. Its speed t minutes after release is given by v of t equal to a negative 0.3 t squared plus 9t, where v of t is in kilometers per minute. For part A, how far does the particle travel during the first 10 minutes? So we are given the velocity function, and we want to know how far the particle travels during the first 10 minutes. So we're interested in an accumulation of distance from time t equals 0 to t equal 10. So we're going to be calculating an integral from 0 to 10. That'll give us the accumulated distance over the first 10 seconds. And we're going to integrate the velocity function, which is a negative 0.3 t squared plus 9t, and that's going to be with respect to t. Alright, so let's find the antiderivative of our velocity function then. So we have a negative 0.3 t cubed divided by 3 plus a 9t squared divided by 2. And then we're going to take this and we're going to evaluate it at 10 and then subtract from that what we get when we evaluate it at 0. So plugging 10 into this, we have a negative 0.3 times 10 cubed divided by 3 plus 9 times 10 squared divided by 2, and then minus what we get when we plug 0 in. So a negative 0.3 times 0 cubed divided by 3 plus 9 times 0 squared divided by 2. Alright, now simplifying this. So we have a 10 cubed. 10 cubed is 1,000 times a negative 0.3 is going to be a negative 300. And the negative 300 divided by 3 is going to be a negative 100. So we have a negative 100 plus, and then we have a 10 squared. 10 squared is 100 times 9, which is going to be 900. And then 900 divided by 2 is going to give us 450. So we have plus 450. And then what we have here is a minus, and then all of this turns out to just be 0. 0 cubed is 0, so that term 0 plus 0 squared, which is 0. So 0 plus 0. So now what we're left with here, a negative 100 plus 450 is going to give us 350. Alright, so when we ask how far does a particle travel during the first 10 minutes, it travels 350 kilometers in this case, because our units is kilometers. Its speed is kilometers per minute. So in the first 10 seconds, it's 350 kilometers. For part B, we want to know how far does it travel during the second 10 seconds. So here, during the second 10 seconds would be from 10 to 20. So we're integrating from 10 to 20. And our velocity function is a negative 0.3 t squared plus 9t dt. Alright, so we've already calculated the antiderivative. Alright, and the antiderivative ended up looking like a negative 0.3 t cubed over 3 plus a 9t squared over 2. And now we're integrating from 10 to 20. So we're going to evaluate it at 20 and evaluate it at 10 and subtract those. Alright, so if we're plugging 20 in here, we have a negative 0.3 times 20 cubed over 3 plus a 9 times 20 squared over 2. And then we're going to subtract from that what we get when we plug 10 in. So if we plug 10 in, we have a negative 0.3 times 10 squared over 3 plus 9 times 10 squared over 2. Alright, simplifying. So in this first term here, we have a 20 cubed. 20 cubed is 8,000. And then 8,000 times a negative 0.3 is going to be a negative 2,400. Negative 2,400 divided by 3 is going to give us a negative 800. Plus, and then over here we have a 20 squared. 20 squared is 400. And then 400 times 9 is going to give us 3,600. And then 3,600 divided by 2 is going to give us an 1,800. Alright, minus, and then I should point out we can save ourselves some work here. This quantity, this entire quantity here, we calculated up here in part A. We calculated that quantity right here in part A, because recall we ended up just subtracting 0 from that quantity. So this quantity in part A turned out to be 350. So we can save ourselves some work here and know that this is minus 350. Alright, so we have a negative 800 plus 1,800, which is going to give us 1,000, and then 1,000 minus 350 is going to leave us with 650. So during the second 10 seconds, so between 10 and 20 seconds then, the particle has traveled 650 kilometers.